In this video, we're going to talk about simplifying negative exponents. Anytime you have a negative exponent, you take that value to the denominator. So if I wanted to simplify x to the negative 7th, I can't have a negative exponent, so I bring the entire value down to the denominator. So x to the 7th is brought down to the denominator. Since you can't just have a fraction without a numerator, 1 becomes your numerator. So x to the negative 7th is the same thing as 1 over x to the 7th. If you have more than one value in an expression with a negative exponent, for example 2p to the negative 5th, pay attention to where the negative exponent is. There's no parentheses around the 2p, which means the negative 5 is only associated with the p. So when you are turning this into a fraction, p to the 5th is on the bottom of the fraction, and the 2 stays on top because the 2 doesn't have a negative exponent. If you had this same situation, but the 2 and the p were both in parentheses, then using your property of powers of products, this would really be the same as 2 to the negative 5th and p to the negative 5th. Both of those values would then be brought to the denominator as 2 to the 5th and p to the 5th. And since we do simplify numbers whenever possible, that becomes 1 over 32 p to the 5th. Now, if for some reason you run across a case where you have a negative exponent in the denominator, for example 2 over b to the negative 2nd, if you have a negative exponent in the denominator, you actually bring it to the numerator. So we would turn this into 2b squared. Now, sometimes you'll be given a problem with negative exponents where there's going to be some simplifying. If you take a look at this example right here, 4y to the 5th x squared y to the negative 2nd power. Okay, if I wanted to simplify this, I would start by bringing my negative exponent to my denominator, so this becomes 4y to the 5th x squared over y squared. Now I'm going to simplify this y to the 5th and y squared because they have a common base and I can subtract the powers. So if I subtract the powers, it becomes 4y to the 3rd x squared. Now, if you look back at the original problem, you also could have used your rule of adding powers. You have the same base here. You've got y to the 5th and y to the negative 2nd. If you wanted to add those powers, 5 plus negative 2 is 3, so that is still y to the 3rd. So no matter whether you bring the exponent down to the denominator of the fraction and then subtract, or whether you apply your rules of adding powers if you're comfortable with negatives, you would get the same answer, y to the 3rd.